Hello guys, in this video we are going to talk about properties of integer exponents. Now let me share my screen. Okay, so properties of integer exponents. Integer exponents. Now you guys know what integers are. I explained it in my previous video. So the first property, a to the 0. So let's call this is 1. So remember, 0th power of anything except 1. So except 0, I'm sorry. 0th power of anything is 1. For example, 7 to the 0, you get 1. 8 to the 0, you get 1. Negative 9 raised to 0, you get 1. What if I write negative 9 to the 0? Are these two the same? Well, in this case, this 0 applies only for negative because I don't have parentheses here. So in that case is negative. That negative is this, and 9 to the 0, that's 1. So negative 1. So anything raised to the 0 is 1. That's property number 1. We'll talk about it again a little bit more later. For the time being, that's it. A to the negative n. This is same as 1 over a to the n, where n is positive in this case. Well, even if n is negative, it works. So for example, let's say 3 to the negative 2, this is 1 over 3 squared, which is 1/9, right? So the idea is, let me write, how about this, if I write 8 to the 3, well, you can take the power down like this, if that works. So the idea is, when you're taking a power below the denominator, sign changes, right? Okay, number 3, let me go to a new page actually. Third property, a to the m times a to the n. M and n, they can be the same, but not necessary. That's going to be a to the m plus n. So for example, let's say 2. So a is 2, 2 to the 3, 2 to the 4. That means 2 to the 7. Now, the reason, because here 2 to the 3, if I take this, I have 2 times 2 times 2, right? And if I take 2 to the 4, I have 2 times 2 times 2 times 2. So altogether 1, 2, 3, 4, 5, 6, 7. So that's how you get. And in this abstract way, this guy is a times dot 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 m times, right? Times this guy a dot m times. Dot means multiplication. So altogether m times and n times, so m plus n times. That is the proof, that is the reasoning why, right? And the next property, well, division, you can guess. This is going to be a to the m minus n. Now let's take an example and understand it. 2 to the 7 divided by 2 to the 5. What do you think? Well, 2 to the 2, right? Because 7 minus 5 is 2. But what's happening is, explanation, 2, 2, I have 7 of them. So 2, 2, 2, 2, 2, 5, 6, 7. Divide by 5 of them, 2, 2, 2, 2. So 5 will cancel. And 2 remains. That is the explanation. How about this? 2 to the 5 divided by 2 to the 8. Now, well, in that case, 2 to the 5 minus 8 is negative 3. Oh, 1 over 2 to the 3. 1 over 8. That's it. And next property number 5. A to the m times n with a parenthesis. Now this is, as you may have expected, a to the mn. Now this case we multiply. Why? Let me explain. 2 to the 3, 4. According to the rule, it's 2 to the 12. Now let's see. So 2 to the, now, okay, listen carefully. This 4, this blue color 4, means I have this guy 4 times. So 2 to the 3, 4 times. That's what that 4, right? Because that's that 4 applied to what's inside the parentheses. Now what you need to do, you need to expand each term. So 2, 2, 2, 2, 2, 2. So this is this. Like that you have another 2 sets. All together you have 12 of them. So that's the explanation. Even with here with abstract notation in sentence, that's the explanation. Next property, AB. So 2 different numbers to the n, that's going to be AN, BN. For example, let's say 2 times 3. Yes, you can call it 6, but let's do it like this. This is going to be 2 to the 4, 3 to the 4. If you are not sure, well, 2 to the 4, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 3 to the 4, 3, 9, 27, 81. So 16 times 81, you can multiply this and check it. So 1 times 16, you get 1296. Let's see. 2 to the 3 is 6. 6 into 4. So that's 6 times 6 times 6 times 6. So 6 times 6, 36. 36 times 6, 216. And 216 again into 6. Let's see whether we are getting the same. 3 left, 9. See, same. So this works. That is helpful, especially in, examples like this, not with numbers like this, but 4x squared cubed. Now how do you simplify this? So this 3 belongs to this power, third power belongs to both 4 and x squared. So 4 cubed and then x squared cubed. So the ultimate answer is 4 cubed x to the 6th, right? Okay, and finally, number 7, a over bn. This is an over bn. Now, these properties are really helpful when we are dealing with simplifying expressions. Now, let me take simplify. So let's simplify this as much as possible. Okay. Now, when you have a problem, when you have a question like this, asking you to simplify, you have to write it properly. First, equal sign, because what you are going to write is equal to this thing. So, see, since this is the first example, what you are doing is actually multiplying a whole lot of things. So you have -2. So let me use parentheses for each, and you don't have to do this, but since this is the first example, so you are multiplying bunch of things. Now other things you can multiply directly. How about the numbers? -2 and 5, yes, you get -10, right? And then like terms, x squared and x to the 3. Now let me show you. The result you need is this, right? So m plus n. So x to the 5th, y 2 plus 3. And y cubed and y, how many? 3 and 1, 4. That's the best you can do, right? Now let's take another example about this. Again, simplify. So 25x to the x cubed y 6 divided by -5x 5th y 4. Now, what you can do here, 25 and 5, -5. So you get -5, right? x3 and x5. So x to the 3 minus 5, which is -2. y6 and y4 in the bottom. So 6 minus 4, 2. Much better way of writing this, -5 y squared, x to the -2 can be written in the denominator x squared using this property. Now actually that's a combination of few properties of this and that one. Okay, now let's see a little bit more examples. How about this? Again simplify, -3 raised to x to the 5th y squared times 4 x 7th y -9 divide by x to the 6th y times y to the -3rd x to the 6th. What do you think will happen? So let's give it a try. So it's all about taking like terms together. So -3 and 4, -12, right? Now let's deal with x. X 5 and 7, and here x 6 and 6. And with y, I have 2 here, -9. Yes, you can do that. So y, now one way is you can take y to the -9 down like this, right? Oh, it's same as, since it's already in top, you can add -9, right? They are the same. But anyway, let me do it like this. So y to the 9 and y -3, that can be taken up with the change in signs, y here. Now we have, you know what, let me do this. Oops, I'm sorry about that. So you know what, let me write it again here. So -12, I have x5, x7. So I'm writing like terms together, x6. And y2, y -9, y, y -3, right? Now, so top you have 12 of them, bottom you have 12 of them. Now in this case, if you want, you can take, if you don't like negative numbers, you can take -9 bottom here, 9. And you have this y, and y to the -3, you can take it to the top by changing the sign. You can do it like this. So -12, x12, x to the 12th, y you have how many? Y you have here 5, and y you have here 10, right? Now let me double check. Yeah, I think correct. Now x to the, in this example, x to the 12 minus 12, so x to the 0, y, and you have 5y down. So x to the 0 is 1, so -12 over y to the 5th is the answer. Okay. Now, let me see. How about this example? 5 r squared divided by r squared is to the 4th. This is an easy example actually. First 5 r squared s to the fourth, because these two belongs to both r and s squared. And then you have r squared s to the fourth, which will cancel nicely, and you get just 5. And how about this example? Negative 3 x3 to the 4 divided by negative 3 x squared to the third. Now what? So negative, you have to be very careful here. Negative 3. Now you can treat, you can treat the denominator as 2 numbers or 3 numbers. What do I mean by that? So if you are dealing it with as 3 numbers, that means I'm taking negative sign as one number, or negative sign negative 1, right? Because negative 3 is negative 1 times 3. And then you have 3, and then you have x to the third. And this 4 belongs to all of them, so you have 4, 4, 4. That's one way of doing it. Or you can treat it as 2 numbers. Now let me write it over here. That means you treat negative 3 as a one number. That's the easiest way, not like this, right? And then you have 4, x cubed, you have 4. And denominator, let me do it in the same way. Negative 3 cubed and x squared cubed. Now what is the easiest way to simplify this? Now let's forget about this. So I believe it's easy for you to think it as 2 numbers, right? But I'm trying to explain it to you more. So you can think negative as one number and break it. But anyway, now at this point, what is the easiest way to simplify? Well, you can actually simplify the negative. That means negative 3 into negative 3 into negative 3 into negative 3. Ultimately, that's going to be positive, because 4 negatives. Negative into negative is positive. So it's 81. Or another thing you can do here, negative 3, you can see negative 3 here, negative 3 here. So as a one entity, so negative 3, 4 minus 3, right? Because here 4, here 3. And then x cubed, you cannot do that in this, because here x squared and here x cubed. So in this case, x to the 12th, it's better to do it like this, and x to the 2 into 3, 6. So here negative 3 raised to first power, which is negative 3 raised to first power, and then x to the 6th. So the answer is negative 3 x to the 6th. So I think that's clear, and I think that's enough examples for this video. So remember, using these exponent rules, you can use them to actually simplify expressions. Okay, thank you.